today you remember we are going to be learning the Pythagorean identities. So you remember Pythagoras, he's the guy with the whole right triangle, a squared plus b squared equals c squared. So that's the first thing you have to remember. And then you also need to remember all of your other identities. And the ones that we're doing now, the Pythagorean, they're a big part of this course. So you remember when we did this, we did this. If you have a point x, y, here, remember this is a right triangle. This is the unit circle, so the radius is 1. So you know that this is x, and this is y, and the hypotenuse is 1. So the lengths of x and y become the legs of a right triangle, whose hypotenuse is 1. And then we use, so remember, it's the leg squared plus the leg squared equals the hypotenuse squared. That's your a squared, b squared equals c squared. So that's where we get this right there. Now, if we remember that x is equal to our cosine, and theta, and y is equal to the sine of theta, we can replace them and do this. And this is our first Pythagorean identity. So this is the first thing. If you square your x, and you square your x, you square your y, put them together, and you get 1. Amazing. This is an identity. And we have all these other identities here, which are good stuff. And what you do have to remember, or you do have to know, is that you can also square these guys. So I can do tangent squared theta is equal to sine squared theta over cosine squared theta. And cotangent squared theta is equal to cosine squared theta over sine squared theta. All of these guys up here can be squared. So cosecant squared is equal to 1 over sine squared. And we always put the squared right there. We don't put it after the theta because that would mean we'd be squaring the angle. We do that, we're squaring the actual sine. You do have to memorize all these. I do have some flashcards I made at cram.com. So if you want to try to memorize them, sometimes search for Barris, and Trigonometry Basics is there, and Pythagorean trig identities is what we're doing today. Those are there. So they're just flashcards, and you can play like little games, I guess. Okay, when we transform these, so we have to go from this to other things. And using what I was just talking about with the sine squares and the cosine squared. So this kind of thing, we can add and subtract and move these things around and make different things. So if you can add and subtract, you don't technically have to memorize these, but you do have to be able to transform them yourself. So I can, subtract cosine squared. Wow, I'm writing really neatly today. This is good. You can subtract cosine squared, and you get sine squared theta equals 1 minus cosine squared. So there's a new one. Identities mean one side is equal to the other side. So I know now that if I have something like that says sine squared, I could also put 1 minus cosine squared, and vice versa. So the other one, you could just go the other way, where I would take sine squared theta. Oh my lord, I keep forgetting the end. Sine squared theta. I have this to start with, and I could subtract the sine. These would cancel out, and you would get cosine squared theta is equal to 1 minus sine squared. Pretty exciting. You can subtract the 1 and get 0. Put this 1 over here, and there's many different things that you can do, but that's the first kind where you manipulate it so that you can add or subtract to either side, and so that's it. So you could also subtract the 1 from over here and take the cosine to the other side, and you get sine squared minus 1. There's lots of different ones, but these are the major two for moving things around. But if you can do anything, any math that you can do to sine squared theta plus cosine squared theta, adding or subtracting, makes a new identity. The other one, you can divide to make identities. So what I'm saying is say I take this guy right here and I divide it by sine squared theta. So this is one of those things that we like you to be able to do on your own. If you can take all of, this trig identity and divide it by sine squared theta. Sine squared theta over sine squared theta, well, that's 1. Okay, I can write. Cosine squared theta over sine squared. Well, cosine over sine is cotangent. So if I was squaring them, then they're squared. And then 1 over sine is cosecants. So 1 over sine squared is cosecant squared, and we created this whole new identity. Okay, and then the other one is if I divide by cosine squared. So if I take sine squared plus cosine squared, and I divide it by cosine, and I get the other two trig ratios. Instead of cotangent and cosecant, I get tangent and secant. Because cosine here is on the bottom, sine over cosine is tangent, so it's tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is your secant squared. So then we create these whole new ones just by dividing. Now you can just memorize those, but it's better to know that you divide by the sine or cosine to get to these. Okay. Finally, you can transform these new ones that we just made into, subtracting. So we can do what we did on number 1 here, where we just subtract them. And cotangent squared equals cosecant squared minus 1. Or you can do just subtract your cotangent here. There's many you can do. I can't do them all because there'd be 25-minute long video. So you could subtract cotangent and goes cosecant squared minus cotangent squared. You just have to be able to add or subtract things to the other sides of the equations to make new identities. So we're going to be doing things with this information. So I'm going to do that one here. So I'm going to subtract my tangent squared. There's many different. This isn't just, I have to remember this particular one because Miss Barris said so. You have to be able to start with sine squared plus cosine squared equals 1 and get to this point here. So you had to divide by cosine to get to this one and then subtract your tangent. And if I put something like secant squared theta minus tangent squared theta, you know that that's 1. So we're going to do a little bit more with this, playing with this, helping you try to memorize them, but you do have to know them. So enjoy.